Video solution to NCERT exercise questions. Class 10 mathematics, we are in exercise 7.1. The topic is coordinate geometry. We are looking at question number 6. Question number 6 had 3 parts in the NCERT textbook. In this video, we are providing solution to parts 2 and 3. Name the type of quadrilateral formed, if any, by the following points and give reasons for your answer. So in each of these parts, we've been given coordinates of 4 points. We need to check out by joining these 4 points what kind of a quadrilateral we are getting and state the property which made us decide what quadrilateral it is. But before that, there's one little thing here. They're saying if any, which means that there's a possibility that these 4 points may not form sides of a quadrilateral. Let's get started. What is the approach we're going to be taking? The approach we're going to be taking is that we're going to be computing the distances between the points, taking them 2 at a time, and then identify the nature of the quadrilateral based on some properties. Let's get started. If you're talking about any quadrilateral, just drawing some random quadrilateral, A, B, C, D. The measures of the sides will give us some indicator about the type of quadrilateral. So the first thing, we'll compute the measures of the sides, lengths of the sides, AB, BC, CD, and DA. This will give us the measures of the 4 sides. For example, let's say the 4 sides are equal. Then, can we determine what kind of a quadrilateral we are talking about? We will not be able to, because 4 sides are equal both for a square and for a rhombus. So how do we decide between a rhombus or a square? We need some more property. The second property that comes along the way is basically the diagonals of the quadrilateral, AC and BD. So we'll compute in all a maximum of 6 sides, the measures of lengths of 6 line segments, the 4 sides of the quadrilateral and the 2 diagonals, and based on that, we'll determine what kind of a quadrilateral we are talking about. We'll just use a slightly different sequence in which we'll compute. We'll compute AB, BC. We'll not go to CD and DA. We'll compute AC immediately. What is the objective? The idea basically comes from this point. They're saying if any. If points ABC ended up being collinear, then by finding out AB, BC and AC, we'll be able to determine that. If they are not collinear, let's go on, find out the measure of side CD. And then let's check out whether these 3 CD, DA will compute before going to DA the measure of BD. Then we'll be able to quickly determine whether BCD are collinear. And then let's compute DA and do a mental check to check out whether any set of these 3 points are likely to be collinear. If you determine that they are not collinear, then let's find out what kind of a quadrilateral we are talking about. What is the only formula that we need to know? We need to know the length of the distance between 2 points whose coordinates are x1, y1, x2, y2. The distance is given by the formula under root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Why not AB, BC, CD, DA and then AC, BD? No harm at all. You'll be actually computing all 4 line segments and then realize they are collinear when you compute the length of the one of the diagonals. So you'll be wasting a lot of time. So we're going to be doing AB, BC, AC, then CD, then BD, and then finally DA. Take this approach, you'll save a lot of time. Let's start with this. Start with the part 2, where these are the 4 points. I'm going to be starting with computing the measure of AB. AB equals under root of x2 minus x1 the whole square, which is 3 minus of minus 3, which is 3 plus 3 the whole square, plus y2 minus y1 the whole square, which is 1 minus 5 the whole square. 3 plus 3 is equal to a 6. 6 square is 36. 1 minus 5 is a minus 4. Minus 4 square is a 16. Root of 36 plus 16 is equal to root 52. Root 52 is divisible by 4, which is a perfect square. So let's write it as 4 into 13. The 4 comes out of the root as a 2. So the measure of AB is equal to 2 root 13. So we found out one side. Of the maximum 6 sides or 6 lengths that we'll have to compute, we have found out the first one. Let's move on to BC. BC will be taking points B and C. x2 minus x1 is equal to 0 minus 3 the whole square plus y2 minus y1 is a 3 minus 1 the whole square. 0 minus 3 is a minus 3. Square of minus 3 is equal to 9. 3 minus 1 is a 2. Square of 2 is equal to 4. So you get the measure of BC to be equal to root 13. The moment AB and BC are not equal, you can eliminate some quadrilaterals. It's not a rhombus, it's not a square. As I mentioned, before going to CD, let's compute the diagonal AC. So that will help us figure out whether ABC are collinear or otherwise. AC, we're going to be taking these 2 points. x2 minus x1 is 0 minus of minus 3, which is 0 plus 3 the whole square. y2 minus y1 is a 3 minus 5 the whole square. 0 plus 3 is a 3. 3 square is equal to 9. 3 minus 5 is a minus 2. Square of minus 2 is a 4. So this is equal to root 13. Let's check out collinearity. It appears right now that AB is equal to BC plus AC. If AB equals BC plus AC, then we know that A, B and C are collinear points. If AB and C are collinear points, these 3 points lie on the same segment. Let's say this is A, this is B, and we have C somewhere here. You cannot have D even if it is somewhere outside, forming a quadrilateral. So ABCD is not a quadrilateral. So step in part 2, by computing AB, BC and quickly jumping to the diagonal AC, we saved ourselves the trouble of finding out the lengths of 3 more sides. So it's not a quadrilateral, right? My spelling is quite bad in this. Quadrilateral, we'll write it again, right? We'll not get it wrong. Quadrilateral, right? ABCD is not a quadrilateral. Quickly summarize it in a printed form. We're going to be computing AB, which works out to 2 root 13. Going to compute BC, which works out to root 13. Computing AC, which works out to root 13. Because AB is equal to AC plus BC, ABC are collinear. If ABC are collinear, ABCD cannot form a quadrilateral. So these 4 points do not form a quadrilateral. Let's move on to part 3. We're going to be running through the same pattern. We'll compute AB, BC, AC. Then we'll do CD, BD and then DA. Find the measure of AB. AB is equal to under root of x2 minus x1 the whole square, 7 minus 4 the whole square, plus y2 minus y1 the whole square, which is 6 minus 5 the whole square. 7 minus 4 is equal to 3. 3 square is equal to 9. 6 minus 5 is a 1. 1 square is a 1. So the measure of AB is equal to root 10. So found out one side. Let's move on to the second side, which is BC. Going to be taking coordinates of point B and C. So 4 minus 7, which is x2 minus x1, 4 minus 7 the whole square, plus y2 minus y1 is a 3 minus 6 the whole square. So this translates to 4 minus 7 is a minus 3. Square of minus 3 is equal to 9. 3 minus 6 is also a minus 3. Square of minus 3 is a 9. Root of 9 plus 9 equals root 18. So in our mind, we can eliminate square and rhombus once we have computed this. Let's move on to AC. The diagonal we are computing right now, this is not a side. AC, we're going to be picking these 2 points. x2 minus x1 is 4 minus 4 the whole square, plus y2 minus y1 is a 3 minus 5 the whole square. 4 minus 4 is a 0. We don't need to bother about it, therefore. 3 minus 5 is a minus 2. Square of minus 2 is a 4. So under root of 4 is equal to 2. Our ABC collinear, root 18 is not equal to root 10 plus root 2. So is not equal to root 10 plus root 4. So ABC are not collinear. So we have got that right now. Let's move on from here. Let's compute CD. We're going to be picking these 2 points. Measure of CD is equal to, I'll draw the quadrilateral here. So we have some idea about what we are talking about. A, B, C, D. We know AB equals root 10. The proportionality is slightly weird here. Root 18 seems to be lesser than root 10, but just live with it right now. So CD, let's find out the measure. We know AC is equal to 2. Let's keep that. CD is equal to under root of 1 minus 4 the whole square plus 2 minus 3 the whole square. 1 minus 4 is a minus 3. Square of minus 3 is equal to 9. 2 minus 3 is a minus 1. Square of minus 1 is a plus 1. So we have this to be equal to root 10. So as we have seen, now we know AB and CD opposite sides are equal. Let's compute the diagonal BD and eliminate the possibility that BCD are collinear. So BD equals under root of x2 minus x1, which is 1 minus 7 the whole square, plus y2 minus y1, which is 2 minus 6 the whole square. 1 minus 7 is a minus 6. Minus 6 square is equal to 36. 2 minus 6 is a minus 4. Square of minus 4 is equal to 16. Root of 36 plus 16 is equal to root 52. Root 18, root 10, and we have this as a root 52. We know that root 52 is not equal to root 18 plus root 10. So we know BCD are also not collinear. Let's compute the last side, which is equal to DA. DA, we're going to be using coordinates of point A and D. 1 minus 4 the whole square plus 2 minus 5 the whole square. 1 minus 4 is a minus 3. Square of minus 3 is equal to 9. 2 minus 5 is a minus 3. Square of minus 3 is again a 9. So this is equal to root 18. So right now we have computed all 4 sides and the 2 diagonals. Let's quickly check out. Root 18 plus root 10 is again not equal to, because we realize that opposite sides are equal. AB equals CD and we have AD equals BC. And we realize that ABC are not collinear, BCD are not collinear. By default, DAB and the other two sets of 3 points will also not be collinear. We have opposite sides equal, so it could be a rectangle or it could be a parallelogram. The diagonals AC is not equal to BD, right? AC is not equal to BD. AC is a 2, BD is equal to root 52. If the opposite sides are equal and the diagonals are not equal, then what we are talking about is a parallelogram. So these 4 points form sides of a parallelogram or the vertices of a parallelogram. Quickly run this through in a printed form. We're going to be computing the length of AB, which is root 10, computing the length of BC, which is root 18, and then let's compute the length of AC. We realize that ABC are not collinear because root 18 is not equal to root 10 plus root 4, right? We know that the measure of CD, we're going to be taking points C and D, works out to root 10. I'll quickly, to help keep track of things, draw a quadrilateral ABCD. We found out the measure of AB to be equal to root 10, BC to be equal to root 18. I'll write down the measure of AC, which is equal to 2. Now compute at CD is equal to root 10. Let's quickly compute BD and verify that whether BCD are collinear or not. We found out the measure of BD, which is a diagonal, which is equal to root 52. Root 52 is not equal to root 18 plus root 10. So we know that BCD are not collinear. Lastly, let's compute DA. DA works out to root 18. Now that we have found out that opposite sides AB and CD are equal, BC and DA are equal, and also the fact that the diagonals AC equals to BD equals root 52. Opposite sides are equal, could be a rectangle or a parallelogram. Given the added information that AC is not equal to BD, the diagonals are not equal, we can deduce that what we are talking about is a parallelogram. So these 4 points form the vertices of a parallelogram. Before you leave, do 2 things. Sign up at online.maxtute.com. All it takes is 5 minutes to get started with your online coaching for Class 10 Math, Class 10 CBSE Maths. And also subscribe to this channel, youtube.com/Maxtute.